So, Priyanshi, can you give me the brief introduction of yourself?
Okay, hi ma'am. My name is Priyanshi Pal. Am I audible?
Yes, you are.
Okay, my name is Priyanshi Pal. Currently, I'm in my seventh semester pursuing BTech from Indira Gandhi Delhi Technical University for Women in Delhi. I'm also trained in RTL and design verification role from VLSI for all. There, I have hands-on on digital electronics, STA, CMOS, Verilog, System Verilog, and UVM.
Okay. So, how you got interested in the VLSI field?
Ma'am, actually, we had a couple of session related to this in our campus. From there, I got to know about, like, from my side, I searched. I also watched various free courses on YouTube. Then I decided to go fully in and pursue and purchase the course and
Okay. So, you know Verilog system, Verilog, UVM.
yes, ma'am.
Okay. So, can you give the difference between the latch and flip-flops?
And the basic difference between latch and flip-flop is that latch is level triggered and flip-flop is edge triggered. So flip-flop will the output in the flip-flop will change at the edge of the clock. And in latches, the output will change immediately when there is a change in the input.
Okay. So, there can be like types of latches and flip-flop. What are they?
Ma'am, SR, D flip-flop, JK flip-flop, T flip-flop.
Um, and in latches?
Ma'am, same goes for latches as well. There are SR latch, JK latch, D latch.
Can we have the synchronous and asynchronous flip-flops?
Yes, ma'am.
So I was talking about that only.
Okay, for synchronous flip-flop, uh, uh, the clock signal is provided. The same clock signal is provided for all the flip-flops, and whereas for asynchronous flip-flop, different clock signals are provided for each flip-flop.
And in latches,
Ma'am, same goes for latches as well.
there can be two types of latches,
Uh,
asynchronous and synchronous.
yes, ma'am.
Okay. So, do you know about the complement?
Complement, ma'am. A complement, B complement.
No, two's complement, one's complement.
Yes, yes, ma'am. Yes, ma'am.
Okay.
And two's complement is basically used to denote negative bit, negative. Like if we want to represent a signed integer.
Okay. So, how many complements can be possible? Like there are only twos or one complement.
Yes, ma'am.
Um, can we have the ninth and tenth complement?
Like I know we can convert into one complement by simply inverting the each bit, and if we want to further convert it into a two's complement, we need to add one at the MSB bit. I'm not sure about ninth and tenth complement, ma'am.
Okay, okay. So, after the interview, you can read about it.
No.
Because we can have all the complements for the base formats. Like you know about the radix.
Yes, ma'am.
So, what is the meaning of radix?
Radix is basically the base, like for binary it is 2, for octal it is 8. for
Yes,
decimal system.
and we have a complement formula, right? R and R minus 1, right?
Yes, ma'am.
So we can have for octal we can write like eighth complement and seventh complement, and for decimal we can write tenth and ninth complement.
Oh,
And for binary it's like twos and one complement.
okay, ma'am.
Okay. Mm, So can you explain me the race in condition?
Ma'am, racing condition occurs when there are multiple inputs at the same time.
Okay. So in JK flip-flop,
Uh, yes, ma'am, there is a racing condition in JK flip-flop.
please explain me that how it happened.
Uh, like, ma'am, in JK flip-flop, when both the inputs J and K are 1, our output gets toggle. So that causes a race condition.
In edge and level trigger both.
No, ma'am, at edge level.
In edge level, the race condition happen.
Yes,
You
ma'am.
can like think,
I'm like, we use master and slave for race condition.
but in level trigger, I think it happens.
I'm not sure about that. The race condition will come at the edge.
Okay, you can read about it after the interview.
Okay.
Okay. So, what is the difference between the wire and drag in Verilog?
Ma'am, wire is a net and reg is used to store the value. Wire is uh, basically a physical format where it is used where it is used to, like, it's a wire, it is used to transport input, like transport signal from input to the output, and whereas reg is the register, it is used to store the output. Reg is used in the procedural blocks and wire is used in the continuous assignment.
And what are the default values for them?
And for reg it is x and for wire it is z.
Okay. And what is the difference between the blocking and non-blocking assignments?
Ma'am, in blocking assignment, RHS values, the RHS value gets evaluated and stores in the LHS are variable, then only the next statement gets executed. Whereas in non-blocking assignment, all the statements can be executed parallelly.
Hmm. Okay. So you are saying that in non-blocking, first the RHS executed, but
Ma'am, RHS,
LHS not executed.
ma'am, RHS gets executed, but LHS have the value of RHS at the reactive region.
Okay. So what are the regions? How
Uh,
many regions are there and what happens?
I'm aware of three regions right now, active, non-blocking, and reactive.
Okay. Can you explain me?
Ma'am, like in blocking assignment, the simulation of the RHS is done in the active region, and LHS gets the value in the active region as well. Whereas in non-blocking assignment, the uh, RHS is evaluated in the non-blocking region, and the LHS gets the value in the reactive region.
Okay. So how many nets can be um, uh, rather than wire, how many nets can be there?
Ma'am, in system Verilog, we can also use logic as a wire.
No, I'm talking about, do you know about the WAND and war and supply one, supply zero things?
No.
Okay. So, have you read about the nets?
Ma'am, in nets, I've only studied about wires.
Okay, so there can be like um instead of wire we can use WAN, war, supply one, supply zero.
Okay, ma'am.
Okay, so you can read about it. Okay. So I'm giving you a question. You have to tell me about what will be the output of this code.
Okay, ma'am. Okay,
Second is correct, and your first block for blocking it's wrong.
ma'am, give me a sec.
For non-blocking it's correct, but
Okay,
for block.
ma'am, sorry. Ma'am, for first one also I've sent.
Yeah, now it's correct.
Mm.
So can you explain me?
So, ma'am, first we have given A as 1 and B as 2. Then we have assigned A is equal to B. So the value of B, which is 2, gets assigned to A. So A is equal to 2. And later, since
Yeah,
then,
there is the sequentially procedure is happening, right? So in blocking, when the A is equal to B is not executed, till it is not executed, it will not go to the next statement. So
yes,
that's why like it's not you printed like A is equal to 4. That's why it's not happened, and it's like A is equal to 2 only.
yes, ma'am.
Okay. And for non-blocking?
Ma'am, for non-blocking, we have assigned A is equal to 1 and B is equal to 2. And
Mhm.
then after that, we have simultaneously, we have assigned B, B's value to 2, which is A is equal to 2. And simultaneously, we have assigned B is equal to 5. So A is equal to 2 and B is equal to 5. Like these
Okay.
two processes are happening simultaneously.
But why B is not equal to 2
Because, ma'am,
in non-blocking? Because the execution happens parallelly, right? So it will not get a time to assign B is equal to 5.
but ma'am, it will print the value which it gets at the end of the simulation time. So at the end, B is equal to 5. That is why it is printing 5.
Why it will print at the end of the simulation time?
Uh, because ma'am, in non-blocking assignment, it evaluates the values simultaneously, but at the end, it prints the value together for each and every statement.
Okay. Do you know about the case statements?
Yes, ma'am.
How many case statements can be there?
Ma'am, there are three case X and case Z. In case nothing is like X and Z are not considered as don't care, whereas in case X and Z are considered as don't care, and in case Z, only Z is considered as don't care.
Okay. Can you give me the output of for this question?
Yes, ma'am.
You are in which year of BTech?
Fourth year, ma'am.
Okay, okay.
We are printing for select line 10x1. So for that, the value will be 2.
No.
Okay, I'm sorry, I didn't. Sorry. It will consider x as don't care. I didn't read xz.
Okay, so
Ma'am, it will print the default value.
no. It's case X, right? So X is the don't care. So it can be 0 or 1, right?
Yes, ma'am. Ma'am, it will print for 1001, the first case,
Yes. Why?
because x will be treated as 0, don't care.
So it will like print one statement only.
Yes, ma'am.
Why?
Ma'am, it will consider x as don't care, so it would be 0. So it would give output for 1001, which is output is equal to 1.
Yeah. Okay. That's correct. So what is the difference between the question mark and X and Z as a don't care?
Ma'am, here if the value, okay. Question marks are not don't care. Maybe it is for if the value is not specified. For this one, it will print the third statement. Output would be 7.
Okay. Why?
Because the select line is 110.
So
And
so you are saying that a question mark is not don't care.
yeah, ma'am.
So what is when the first statement will be printed for what value for the select line?
Ma'am, maybe if the select line would be a 1xz, so it might print first statement because it doesn't care about the last two LSB bits of the select line. But since we are getting exactly like we are providing the select line as 110, and for 110, the output is defined in our code, so we will get 7 as the output.
So you are saying that in case of 1xz select line value, it will print the first one.
Yes, ma'am.
No, but it will print the default value in that case.
Okay. So, ma'am, so it might be that if we don't provide, if we only provide one bit as a select line.
Okay. But in that case only it will print the default value.
For that case, also it will print the default value if we provide
Yes.
only one. Okay, ma'am.
Yes.
Actually, I haven't seen question mark before. I don't know what does that mean.
Okay. Okay, no problem. We can move to the next question. So, do you know about the repeat statement?
Yes, ma'am.
So, what is the use of the repeat statement and what is the difference between the for loop and repeat?
Okay, ma'am. The use of the repeat statement would be if you want to execute a chunk of code again and again, we need its output again and again. So we can use a repeat. For example, if you want to print number from 1 to 10, for that we can construct a for loop, and we can uh, uh, like for that we can use a for loop as well. And
Mm.
like with the, you by using just a for loop we can print a number from 1 to 10. But for example, we want to print VLSI for all 10 times, so we can just use a repeat bracket में 10 and print VLSI for all, so it would print VLSI for all 10 times. We can also use it with the help of for loop. It would be quite efficient if you use the for loop.
Okay, so do you agree that the for loop is dependent on the I index,
Yes, ma'am.
and but the repeat statement is not dependent on any variable.
Yes, ma'am. Yes.
Okay. So can you like generate the clock in different methods?
Uh, yes, ma'am.
Please, can you generate it in the online simulator and show me
Yes, sure, ma'am.
online or offline in which you are comfortable?
I need to share my screen.
Yes, yes.
Ma'am, we can use a initial always block, and we can also use a forever statement for clock generation.
What else we can use?
A forever statement.
Okay, please, can you write it? Write the code for it and
Okay.
run it. हाँ जी.
Okay, ma'am, I'm running it.
तो हाँ रिज्वाइन हो गया।
Yes,
ओके।
sir. Ma'am, I don't know why it is showing error. And we can use a forever statement, or we can simply assign a delay, and after 5 units of time, our clock will revert.
Please,
Sorry, ma'am.
can you repeat?
Ma'am, we can assign a forever statement also, or we can simply assign a delay, like after 5 unit of time, our clock will revert from 1 to 0.
Mm. Can you like simulate it using the dollar monitor and show the output in the console?
Yes, ma'am. I don't know why it is showing error. There might be a small syntax error.
Okay, so we can like write it using the initial always and
Forever.
okay, so can you have written the initial block inside the always block? Can we write it like this?
Yes, ma'am.
Can we do the nesting of the procedure block?
Yes, ma'am.
Mhm. After the interview, please read about it.
Okay.
Okay. So we can write it using the always, forever, and initial. Can we write it using the repeat block?
Yes, ma'am.
Please write it.
Oh, ma'am, if we remove this,
We can read the error. Um, please see the what we are getting the error.
a net is not a legal value in this context.
Yeah. So you have declared the net inside the procedure block.
And maybe we could. And it got stimulated, I think. It is not showing any error now. I just assigned clock as a reg.
What are you saying?
Ma'am, I assigned clock as a reg and now it is
Okay.
not showing any error.
It is showing warning and it's not get executed. You can like write the monitor statement and see the output.
And it is showing X as the output.
Yeah, the by default value of the rec. So why it is showing like you have done some any mistake, I think.
Yes, ma'am. And I'll look into this after the interview.
You have to initialize the clock for getting some values.
And how do we initialize? I'm like, we have initialized over here.
Where you have initialized?
Over here.
No, you have declared. You have to initialize, like you have to
Okay,
give.
okay. Yeah, got. And I haven't done hands-on on Verilog for quite a long time.
You can like check after the
Yeah,
interview. You have used both the always and initial blocks. You have to check this.
okay.
Can you explain the can you give the output of this question?
Okay, so ma'am, initially we have given x as 0, y as 0, and then we have used intra delay. X is equal to, it will wait for 5 units of time, then 1 will be assigned to x, then our y is equal to x. And after delay, we will get x is equal. And we will get y as 1 and I'm sure about the value of y. We will get y as 1 and x, maybe we will get x also as 1.
Do you know about the generate block?
Oh, yes, ma'am.
Please explain and give
So,
the
ma'am,
example also.
uh, ma'am, I know a bit about generate block. Generate block is basically used to generate, ma'am, it is used to generate inputs, random inputs. Like I even know the syntax, we use genvar, something like that for generate block.
Okay, so I can check by giving you the example also. So can you like give the output for this question?
It will give outputs like for 1 it will give odd, for 2 it will give even, for 3 it will give odd, then for again 4 it will give even.
Okay. So it will start from 1 or 0.
Ma'am, it will start from 0.
So for 0, what will the value?
Ma'am, for 0 it will give even.
Okay. And alternatively, it will give, right?
Yes, ma'am.
Okay. So, so what do you mean by the randomization?
Ma'am, in system
System
very
Verilog. Huh.
Ma'am, in system Verilog, randomization is basically used to generate random inputs for stimulation and verification purposes because we need to check the functionality of our design. So for that, we need a huge amount of random data which we can use to execute with the help of our design to check its functionality. Also, with randomization, we can use constraint to generate a specific range of inputs as per our desire.
So what happens like if you try to randomize the static class property?
Sorry, ma'am, if we try to randomize,
The static class property.
ma'am, it will give random values for that as well.
No, it will not give the random value. It will give an error.
Okay.
Yes. So what is the difference between the rand and rand C?
Uh, Ma'am, rand is used to generate random values, and I guess if we use rand C, we won't require uh, to use randomization again in our module. I'm not sure about this answer, but I think like if we use a rand bit, then later if we access that, we need to use dot randomization. But if we use rand C, we won't require to use randomization again.
Okay. So can we randomize the bit, reg, logic, and integer directly?
Can we use randomization to generate?
Can we randomize bit, reg, logic, and integer directly?
Uh, yes, ma'am, by using the rand keyword, we can.
Right, can you repeat?
Ma'am, using the rand word, we can generate random values for bit.
Yeah. And what is the difference between the soft and hard constraints?
Soft and hard. And I haven't read about soft and hard constraint.
Okay. What is the use of the $u random range?
Dollar random range, ma'am. It is by using this we can generate random values in between a range. Like we can generate random values in between 1 to 20.
Can you explain in brief, like?
Like, ma'am, if we want random values in between 1 to 50, so we can provide the range 1 to 50 and it would print dollar random range would print random values in between 1 to 50 only.
Okay, so what is the difference between the else random functions and what is the unique thing in the $u random range?
And I haven't studied much about dollar U random.
Okay, okay, no problem. Have you done any projects?
Yes, ma'am.
Which projects?
Ma'am, asynchronous FIFO, ABP protocol, I2C, SPI.
You are?
No, ma'am. I'm doing UART. I haven't completed.
Okay, so you know about the packed and unpacked array.
Yes, ma'am.
Please explain it.
Uh, Ma'am, packed array means the location is at the one place, and in unpacked array, the locations are random. Like if we provide the vector width before the variable of the array, like uh, if we provide it before, then it's a packed array, and if we provide it after the array name, the it would be the unpacked array.
Okay,
Like,
so I've given you the question. So this is packed or unpacked array.
okay. This one is the packed array.
So please give the output.
Send the output.
Okay, it's correct. So this is the example of which array?
Ma'am, it's the unpacked array.
Okay, it's only the unpacked array.
Like, ma'am, we'll have four different location here. Four different location of 1 bit. Of 2 bits, sorry.
Okay, so this is the mixed bagged array.
Yes, ma'am.
Okay. So please give the output.
Okay.
Do you know the STA?
Yes, ma'am.
So what is the difference between the propagation and contamination delay?
Ma'am, propagation delay means the time required by the clocking signal to pass through a net or a cell, whereas a contamination delay is the time required for the output to change or to reflect the change when input uh, to reflect the change in the input at the output side.
Do you know about the jitter?
Yes, ma'am. Jitter refers to the deviation of the clock edge from its ideal position.
Okay, so what is the uncertainty?
Ma'am, uncertainty comprises of the clock skew plus jitter plus noise margin.
Okay, so what do you mean by the setup and hold time?
Uh, Ma'am, the amount of time required for the input to be stable before the clocking edge is known as the setup time, and the amount of time required by the input to be stable after the clocking edge is known as the hold time.
Okay, so why does the placement of the clock source and flip-flop becomes very important and challenging?
Placement of the clock source.
Placement of the clock source and flip-flop.
Okay, ma'am. So, ma'am, uh, Uh, ma'am, the time required by the clocking signal to propagate from the clock source to the flip-flop is known as the clock latency, uh, and it plays a very important role. So yeah, it if we place a flip-flop and a clock source very far away, the latency would be very large.
Okay. Okay, fine. I think that's all for today.
Okay, ma'am.
So, do you have any questions for me?
Oh, ma'am, can you just list some of my weak points?
Um, I think you should do Verilog output questions more.
Okay, ma'am.
Um, and you can like practice by writing the Verilog codes,
Yes,
different Verilog codes. Okay.
okay, ma'am.
So in the next interview, I will more focus on your like projects.
Okay,
So
ma'am.
please complete the UART
Okay,
also.
okay,
Okay.
okay.
Thank you. Any
Thank you.
more question?
No, ma'am. Thank you very much.
Okay. Thank you.